Okay, this is the final video for Unit 2, and we are looking at something called dimensional analysis. This is how we take one value and convert it into a different but equivalent value. A conversion factor is a ratio of equivalent values that have different units. Kind of a difficult definition for something that's not actually that difficult. A conversion factor shows the relationship between two different units. So, for instance, some good ones to know are 2.54 centimeters in 1 inch. This is a conversion factor. Could be 12 inches in a foot, 12 inches in 1 foot, 3,600 seconds in 1 hour. And we could go on and on with these. 1 kilogram is 1,000 grams. Here's one that works with water. 1 gram of water is 1 milliliter of water. And we're talking about pure water. And that's in the same unit. If you go back towards the beginning, you'll see this one. Some other interesting ones I've seen in years past, I've had students that say there are 5 toes on a foot. So that's technically a conversion factor. So these could be anything as long as they are two equivalent values with different units. Dimensional analysis is an extremely important concept for this course. We have to be able to change units from one type to another. It's really an approach to problem solving using conversion factors to change one unit to another. They teach this in your math class, and by the time you come to my class, you've probably heard of unit multipliers, and maybe you've had some extensive work with it too. Dimensional analysis uses conversion factors that are expressed as fractions. The first thing we're going to do is start with our given value. The number that we are given in the question is the number that we should start our calculations with. Then find a conversion factor to relate the units of the given value to a different unit. Some calculations only require one conversion factor. Other calculations may require 3 or more. Dimensional analysis requires some planning before you work with your calculator. It's not a good strategy to pull out the calculator and just start typing. You will get an answer, but it may not be the right answer. What we need to do first is stop. We need to plan it on paper. We need to write down all of the conversions. We need to make sure that things cancel. And we need to make sure that everything is in order before we start working with the calculator. Each conversion factor should do something. It should cancel one unit and introduce a new unit. And it's important that we keep track as we go along. As we go through some examples, you'll see that I only take one step at a time. I don't like to plan the whole thing at once. I like to look at the pieces first. So I put one piece of the puzzle in at a time, and then once I've got to where I need to be, then I can move on and do the calculation in the calculator. A conversion factor on the simplest level is what you want over what you have. Now there are more complicated situations where you start with units that are on the top and the bottom. But as a general starting point, what you start with, what you have goes on bottom, and the unit that you want is going to go on top. First thing I look at is simple stuff. So eggs to dozens. We could add this to our list. So convert 32 eggs to dozens. Remember, we start with our given value. The only thing I know right now is that I have 32 eggs. I'm going to set it over 1. It's not going to change the value, but it's going to line it up better with the conversion factors. So then we need to find a conversion that relates eggs, what we have, with dozen, what we want. It's generally common knowledge that there are 12 eggs in a dozen. Most people are familiar with this conversion factor. So when I say I have 32 eggs and we want to know how many dozens, the eggs actually cancels out, and in the number of dozens we have 32 divided by 12, which is 2.7 dozen eggs. Example 12, how many seconds are in 800 minutes? First thing we do, start with the given value. That's 800 minutes. Set it over 1 and it'll line up better with the conversions. We want to know how many seconds. So we have minutes, that'll go on bottom. We want seconds, that'll go on top. And we know that there are 60 seconds in 1 minute. That gives us the unit we want. Minutes will cancel out. And so we end up with 800 times 60, and that is 48,000 seconds. How many years are in 500 days? Before I go any further, take a look at this number that I'm giving us, 500 days. 500 with a decimal point tells us that we have 3 significant figures here. We're going to start with the given value, and we want to know how many years. So we have days, we want years. The relationship very generally is 1 year for 365 days. If you want to be a little more specific, there's 365.25 days, or if you want to be really specific, there's 365.24 days. We're just going to stick with 365. So we're going to have years, days will cancel out, and we're going to end up with the 3 significant figures, 1.37 years. Example 14, how many miles are in 12,000 yards? You could do this one a couple of different ways. So here's 12,000 yards over 1. You could do 1 yard is 3 feet, and then 5,280 feet in a mile. So yards would cancel and feet would cancel, and we come up with an answer in terms of miles like we want. It's 6.8 miles. Now there's another possibility, and that is 12,000 yards. Let's say that we know in 1 mile there is 1,760 yards. Again, we've canceled the yards and we've got miles, and we come up with the same answer, 6.8 miles. So in a lot of these, you could have 2 steps, and a lot of them there really is more than one way to get from your given value to your solution. So keep that in mind as you're approaching questions. There could be more than one way to answer. The last example for now, what is the cost of 8 onions if 3 onions weighs 1.5 pounds and the price is 20 cents per pound? So this one is going to require a little extra thought because we have a lot of values that were given to us, but only one of them only one of them works as an appropriate starting point. So first I would look at these and try to figure out which ones are conversion factors. So I would say 3 onions at 1.5 pounds is a conversion factor. So it's not our starting point. And we have 20 cents per pound. That's a conversion factor. I would not use that as our starting point. So I would say the best place to start here is with our onions. 8 onions set over 1, so it lines up appropriately. And my first conversion factor. Now I want one that relates onions to something else. So I want to make sure that onions cancels. Well, I don't see anything with onions on bottom, but I do see this one, 3 onions per 1.5 pounds. We could just as easily change that and say that 1.5 pounds is 3 onions. Those are equivalent values. There's not a problem if we just flip it upside down. So 3 onions are 1.5 pounds. Keep track of our units as we go. Onions cancels, and we have pounds now. And the next thing, we want something that cancels pounds, and we want to know what is the cost. So we're looking for the price. So 1 pound is 0.20 or 20 cents. So now all we have to do is solve this thing. And so we put it in our calculator. Let's cancel the units first. And we find that the cost of 8 onions is 80 cents. Now with significant figures here, since we're talking about money, round to the nearest cent. In the future, we're going to be doing more specific chemistry examples, but for now, these are a good starting point.